Hi guys, welcome back. So today we are gonna follow up our earlier video. We are going to continue the exponent unit. Okay, in the earlier video we introduced all 5 exponent rules, including the bonus exponent rule. So the first one was the product rule for exponents, zero exponent rule, negative exponent rule, quotient rule, power rule, and then this bonus negative exponent rule. What we did, the first video was pretty long because we did a quick examples to illustrate each rule. Now we're not gonna do that many. Okay, we're only gonna, I think last video we did at least 30 problems, if not more. Now we're gonna limit it to however many those are. I think it's 7. Okay, I lost track. Okay, but of course they're a little bit spicier, so it's gonna take us a little bit more time to knock out. Okay, so let's do this. So the directions read: simplify the expression. And when it comes to exponents, it's implied that we always have positive exponents. But as a gentle reminder, because I'm so nice, contrary to popular belief, that's our chain of thought. Okay, so we are asked to simplify the expression. And then as a gentle reminder, it says answer should contain positive exponent only. I think this word only is redundant. Okay, so answer should contain positive exponents. Okay, you handle it however you can. Okay, so in this case we have a product of 1, 2, 3, 4. We got 4 things multiplied by 1, 2, 3, 4, 4 things. So we got a product of 8 things total. So we are going to group the integer factors, and then we're going to group the variable factors that have the same base. Okay, so let's go ahead and do this. So I'm going to go ahead and use my highlighter. Okay, when we group the integer factors, product of -2 and 5 is -10. Hey, that was fun. Okay, but now for stuff that I have to remember, product of the a's. So I was like, oh man, how do I multiply 2 things that have the same base? I forgot, and then we're not gonna have these rules on the test. We have to remember them. So I was like, I'm so frustrated. Let me vent out my frustrations. I'm so mad at myself for forgetting. Remember, we have to speak like that, okay? Else it's not gonna work. Okay, once we vent out our frustrations, we're like, oh, we got this. If we have a multiplication problem, surprise, if we have a multiplication problem and we're multiplying 2 things that have the same base, we're going to keep the base and add the exponents. So mad I am no more. Okay, so product of the a's, the base is a, and the sum of this, let me go ahead and zoom in. Okay, the base is a, and the sum of the exponents, namely 8 and 10, will give us 18. Okay, 2 products down, 2 more to go. Product of the h's, we're going to keep the base, which is h, and then we're going to add the exponents. Sum of -6 and 3, I believe it's -3. Okay, for the grand finale, product of the k's, we're going to keep the base and then add the exponents. Sum of 4 and -4 is 0. Fantastic. So we're good. Okay, we multiplied. But now the question is our answer accepted for full credit? Maybe, maybe not. So first of all, I can simplify k to the 0 power. Okay, so gentle reminder, 0 exponent rule. For any number that's not 0, when you raise it to the 0 power, that will always simplify to 1. Okay, so it's something that we're going to digest. If you want to see like why, then you stay after class. So this will simplify to 1. Cool. Now, so let's go ahead and write down what we have. Okay, so we have -10 times a raised to the 18th power times h to the -3rd. Okay, so this is correct. Unfortunately, it is not accepted for full credit because our answer should only contain positive exponents, and we have a negative exponent. Our answers may be negative, it's just the exponents that cannot. So I'm cool with the -10. My issue is just with the h. Okay, so if you have a negative exponent, you gotta go where? To the other side. Okay, that's how we attack it. If we have a factor and we're raising it to a negative power, to make the exponent positive, you're gonna move the factor to the other side of the fraction bar. So like if you're in the numerator, you come to the denominator. If you're in the denominator, well, you're gonna come up to the numerator and then you switch out the exponent. I'm gonna link the part 1 of this unit in the description below. But remind me to do that. Email me if I forget. Okay, so coming to our problem, so let's go ahead move this h to the other side of the fraction bar that we're about to make up. Okay, so the 10 and the a stay put, so the negative 10 and then the a is the h that we have issue with. To make the exponent positive, we're going to move the factor to the other side of the fraction bar. Sorry, I need to finish my sentences. Okay, you move the factor to the other side of the fraction bar, and then you switch out the exponent. So all our exponents are positive, our fraction is reduced, there's nothing to cancel the 10 with, nothing to cancel the a with, and this doesn't look like a 3. Okay, your writing should be better than mine. Okay, so again, we're doing a total of 7 problems. This is our first. Let's go ahead and knock out the next set of problems. Problem B. So we have 5 times n to the 12th over 30 times n to the negative third. Okay, so we have a fraction. Let's go ahead and reduce it. You know what? I'm going to attack first what I felt comfortable with before the course started. I'm going to attack the numbers. So 5 and 30 have a common factor of 5. Let's do this. 5 goes into itself once and into 36 times. Cool. Now, what about the ends? If you're having a moment, vent out your frustration. Silly exponent rules, they make me so mad. Again, it's reference to the first video. If we have a division problem, we're going to keep the base and subtract the exponents. And it doesn't matter which exponent you subtract, but the recommendation was this. To avoid having a negative exponent in the solution, always subtract the smaller exponent. In this case, the smaller exponent is negative 3. Well, guess what? We're going to subtract the negative 3. So n to the negative third goes into itself once. And to the top factor, we're going to subtract that exponent. So we're going to subtract that negative 3. Now, I understand that this will turn into an addition problem, but bear in mind the main operation was indeed subtraction. Okay, so always subtract the exponent, and then that difference will give us 15. Now the question that I get, oh, how do I know where the n goes, top or bottom? Well, if you were able to reduce the numbers, the variable should be no different. Just look at what the result is after you cross cancel. Like for the 5 and 30, why do we put the 1 on top? Oh, because 5 goes into itself once and the 5 is in the top. Why do we put the 6 in the bottom? Oh, because 5 goes into 36 times and the 30 is in the bottom. So we're just dividing. N to the negative third goes into itself how many times? Once. Okay, where is this bad boy? In the bottom. So that's why the 1 stays in the bottom. N to the negative third goes into n to the 12 how many times? Oh, n to the 15 times. And it stays in the top. Okay, I don't know if you understood what I was trying to say. Okay, so in the numerator we have 1 times these n's, so we'll just have n to the 15th. And in the bottom we just have product of 6 and 1, which is 6. Fantastic. Okay, let's go ahead and knock out problem C. Okay, this one's not on the test, but I wanted to remind you of another rule. Okay, we have x squared. I'm going to change it to the 4th power. Okay, so in this case, I cannot be mad at myself because I don't have a multiplication problem and I don't have a division problem. So I have to incorporate the power rule. I need to speak to my friend. Okay, I had offered extra credit to the class if they can incorporate my maths with the power rule, but I forgot the rule. Sorry, friend. Okay, so the power rule, if you're raising powers, you're going to keep the base and multiply the exponents. Okay, x squared raised to the 4th power. X squared raised to the 4th power. How are we going to handle it? Power rule. Keep the base and multiply the exponents. So that will give us x to the 8th power. Fantastic. Where am I? D. I think D is the next problem in the alphabet. Okay, D. We have negative 3 times x to the 4th all over y squared. Innocent enough. Let's make it spicier, and we are going to raise it to the 3rd power. Okay, so we have a fraction. Let's go ahead and raise it to the 3rd power. The first thing that I recommend is to follow order of operations. So in order of operations, we take care of grouping symbols. But as we look at the grouping symbol, inside the grouping symbol, we have a fraction. And what can we do with fractions? We can reduce them. But there's nothing to reduce. The 3 is not going to cancel with anything. There's no x's to cancel. There's no y's to cancel. So it's actually reduced. what do we do after? Okay, after grouping symbols, we take care of exponents. So let's do that. So we're going to apply the power rule. And even though this one is like 100 times spicier, I said it before, if you're cool with the original power rule, the rest will follow. You're just going to apply the power rule to each factor one at a time. So the first factor that we see in the numerator is a -3. So let's do this. So this will give us -3. What's going on with the -3? It's being raised to the third power. Since our base is negative, let's go ahead and wrap it up. Let's take the next factor and raise it to the third power. Okay, power rule, keep the base and multiply the exponents. 4 times 3 will give us 12. The question is, how come I didn't evaluate -3 to the third power? It's because, to tell you the truth, I don't know what it is. Okay, so that's why I wrote it down. Okay, over. Okay, we're done with the top. Let's apply the power rule to the bottom. Denominator, raised to the third power. Power rule, keep the base and multiply the exponents. The base is y, and the product of the exponents, namely 2 and 3, is 6. Fantastic. So what do we have left? We just have to evaluate. -3 to the third power. -3 times -3 is 9, and 9 times -3 is -27. See, who says we're too old to use our fingers? To this day, I always use my fingers. Okay, so that will give us -27. There's nothing to do with the x, and there's nothing to do with the y. Okay, I always second guess myself. It's a bad habit. Let's look at our answers and see if it's accepted for full credit. So there are no negative exponents, so that's cool. Can we reduce it? No, that's it. Nothing to cancel the 27 with. No x's, no y's to cancel, so we're good. Okay, let's go ahead and do another spicier problem. We have a total of 7 problems. We knocked out 4. We need 3 more. Okay, problem E. Where am I? Problem E. Problem E, we have spicier. Okay, excellent students. Fantastic. We have 3 to the -4th times x to the -3rd over 3 to the -3rd. X to the -6, and if that wasn't spicy enough, let's go ahead and raise it to the -2nd power. Oh, is this gonna be on the test? You know what? If you just pretend that every problem is gonna be on the test, nothing will surprise you. Okay, how should we handle this? You know what? It's a personal choice. Some students start attacking this outer exponent. I'm not in that habit. Why? Because I think of order of operations. Order of operations. Grouping symbols, exponents, and then the rest will follow. So I'm going to stick to my plan. Grouping symbols first. So inside the grouping symbol, we have a fraction. So what do we do with it? We reduce it. Okay. Now, for the 3's, it would be really nice if I can just cross cancel right away like I did earlier. But to tell you the truth, this is like out of my zone. So I'm just gonna make this exponents positive. Okay, we can use the quotient rule, but I'm gonna try to make your life a lot easier. Okay, so we're gonna bring this 3 down and this bottom 3 up. Okay, let me go ahead and do that. Okay, this top 3, because it's being raised to a negative power, to make the exponent positive, you got to move the factor to the other side of the fraction bar. So the top one comes to the bottom. To make this factor, to fix it so this factor is also raised to a positive exponent, you're going to move the factor to the other side. So in this case, bring it up. For the x's, we can use the quotient rule if we like, but why don't we just use the same strategy? Okay, to make this top x being raised to a positive power, let's move the factor to the other side. So we'll bring it down. This bottom x, to fix it so it's being raised to a positive power, we move it to the other side. So again, please reference the other video. Okay, if you jump to this one, I'm sorry, this is gonna be a tougher video to follow. You need to follow the first video, because that's why I break down all the rules. Okay, so let's bring down the rest of the problem. Alright, so again, I'm not going to look at this outside exponent because I want to focus on this. So we have some options when we evaluate the integers. We can evaluate 3 cubed and 3 to the 4th, and then cross cancel. Or you know what, since we're dividing two things that have the same base, why don't we go ahead and use the quotient rule for exponents? So silly exponent rules, they make me so mad. So if we have a division problem, let's go ahead, keep the base and subtract the exponents. So if we subtract the smaller exponent, namely 3, let's do this. 3 to the third goes into itself once, and in 3 to the fourth you subtract the exponents. Let me go ahead, zoom in. 4 minus the other exponent will give you 3 to the 1, and that just simplifies to 3. Quotient of the x's. So again, you're dividing two things that have the same base. How are you going to handle it? You're going to keep the base and subtract the exponent. So when we subtract the smaller exponent, namely 3, x to the third goes into itself once, and into the other x, you're going to subtract that other exponent. So that will leave us with x to the third in the numerator. It's not a guessing game where does the x and the 3 goes. Just copy down your work. In the numerator, we have 1 times x cubed, which was just x cubed. In the denominator, we have 3 times 1, or 3. Okay, that is a lot, but we're getting there. Now at this point, how are we going to handle it? There's different ways to go about it, but I really have an issue with this outside negative exponent. Okay, so at this point we're going to apply that additional negative exponent rule. If we have a fraction and we're raising it to a negative power, to make that exponent positive, we're gonna like take the reciprocal and switch out the sign. So in semi-English, we're applying the negative exponent rule to the top and the bottom at the same time, or simultaneously. When we, however I say that word, when we apply the negative exponent rule to the numerator, to make the exponent positive, we're going to go ahead and move it to the other side. So bring it to the bottom. When we apply the negative exponent rule to the bottom, to make the exponent positive, you're going to bring it to the top. So now that we've applied the negative exponent rule to the top and bottom at the same time, now we can safely raise that quotient to a positive power. And at this point, nothing is stopping you. Go ahead, apply the power rule to the top and then to the bottom. When we take 3 and square it, I believe that's 9. When we take x cubed and square it, power rule, keep the base and multiply the exponents. The square of 3, power rule, keep the base. Apparently I need to write it out. This is why we don't do videos at the middle of the night. Alright, cool. Power rule, keep the base and multiply the exponents. So we keep the base x and then multiply the exponents. 3 times 2 is 6. So that's our answer. All the exponents are positive. We still have a fraction. It's reduced, so we're good. So I said we were doing a total of 7 problems. That's our 5th one. We have 2 more and we're out. Okay, go ahead, look for it. Okay, can you see? I don't even know if you can see the paper. Let me write the letter F. Okay, oh, you have to zoom out. I forgot. Okay, alright, problem F. What? You want another fraction? Oh, I love your enthusiasm. So we have 28b over 8a squared b to the negative third. And to make it even spicier, we're going to raise it to the negative third power. So there are different ways to approach this problem. As long as you apply an exponent rule correctly, it doesn't matter. Okay, we'll get the same answer. I can only give you recommendations. Okay, order of operations, grouping symbols, exponent, and then the world. So grouping symbols, let's attack the grouping symbol. Inside the grouping symbol, we have a fraction. So what can we do with it? Reduce it. Handle it however you want. Okay, we don't have a lot of negatives. I'm just going to keep that inside negative there for now. Okay, so let's go ahead and cancel out for the integers. 20 and 8 have a common factor of 4, so let's do this. 4 goes into 8 2 times, 4 goes into 20 5 times. Fantastic. 1 division down, 2 more to go. Quotient of the A's, if you're having a moment, vent out your frustration, and then remind yourself that if you have a division problem, you're going to keep the base and subtract the exponents. So we're always going to eye the smaller exponent. So in this case, oh, that's as big as it's getting. The smaller exponent is 1. So we're gonna reduce or cancel by or divide by a to the first power, or just a. A goes into itself once, and into a squared you're gonna subtract that other exponent, so that will leave you with a to the first, or just a. Quotient of the b's, the exponent is 1. The exponents are 1 and -3, and last time I checked, -3 is the smaller exponent. So let's go ahead divide by b to the -3rd. B to the -3rd goes into itself once, and into the other b we subtract that other exponent. Okay, so 1 minus -3 will give us 4, I think. That will give us b to the 4th. Okay, and then copy your results. In the numerator, we're left with the product of 5, 1, and these 4 b's. So let's go ahead and write it, and that will give us 5 times b to the 4th, and that's all over product of 2a and 1, or just 2a. So it's like, oh, I can breathe. I know, cool. So now, do what you gotta do. You can evaluate, but I don't like that. Okay, I don't really like raising it to a negative power. So with your permission, we're gonna fix it. So we're raising it to a positive power. So we're gonna bring the top to the bottom and the bottom to the top. Okay, I'm gonna try to say fewer words because I've said longer words in a bit. We bring the top to the bottom and the bottom to the top. I kind of feel like that's like a song. I don't really listen to English music, so I don't know. Okay, so let's go ahead and apply the power rule to both the numerator and denominator, one factor at a time. You know me, I make mistakes. So how am I going to overcome them? By writing down things that I forget. Power rule. If you're raising powers, you're going to keep the base and multiply the exponents. Let's look at the numerator. First factor, when you raise it to the 3rd power, was 2 to the 3rd. Use your fingers. 2 times 2 times 2. I believe that gives us 8. And if you're having a moment, then just show your work. Just write 2 to the 3rd and then evaluate later. Next factor, raising powers. You're going to keep the base and multiply the exponent. So that will leave us with a raised to the 3rd power, because product of 1 and 3 is 3. Okay, top is done. Let's attack the denominator. For the denominator, 5 to the 3rd power. I want to know what's 5 times 5 times 5. And with some magic, that gives us 125. Okay, b to the 4th raised to the 3rd power. Power rule. Keep the base and multiply the exponents. So that will leave us with b raised to the 12th power. We have a fraction, it is reduced, so we're good. Okay, for the final problem, for the final and 7th problem. Okay, cool. I already showed you my list of problems, so I can't add any more problems. So we have, where am I? 3 times x to the -1st power times y to the 3rd power, all over 3 times x times y to the -1st. The denominator is being raised to the 3rd power. The numerator is not spicy enough. We're going to raise it to the -2nd power. And for a little bit added kick, multiply it by 9 times x to the -9th, y to the 5th. Is this one going to be on the test? Remember what I said. If you just pretend that every problem is going to be on the test, then nothing will be a surprise. Okay, so this problem, there's so many different ways you can approach it. Okay, we're not going to approach it all those different ways. This is how I'm going to approach it. Okay, now, I would love for the numerator. I would love to be able to apply the power rule right now. But this is the thing. If you ask me what 3 to the -2nd power is, I'll be like, I don't know. Okay, so when I don't know the answer, I need to fix it so I do know. So what are we gonna do? We're gonna raise this product to a positive power. Okay, how do we make the exponent positive? By moving the factor to the other side of the fraction bar. Okay, if you need to remind yourself, then go for it. Okay, you move the factor to the other side of the fraction bar, and then you can safely switch out the exponent, make it positive. Okay, so that numerator, that base, we're going to move it to the other side of the fraction bar. You're going to have to keep the base as is. So the base reads 3 times x to the negative first. Okay, we don't switch out the base. Okay, the base stays the same. The only thing that we switch out is that outside negative exponent. Okay, so the base is 3 times x to the negative first times y cubed. Okay, base has been relocated. Now that we move the base to the other side, now we can safely raise it to a positive power. Times what? Well, we already have something in the denominator. Times 3 times x times y to the negative first raised to the third power. Let's go ahead, put a 1 in the numerator. Times 9x to the negative 9 y to the fifth. And again, there's so many different ways that we can approach this problem, but I don't think you want to stick around for that, so I'm just gonna pick one. Okay, so let's go ahead, clean up that denominator. So we have 1 over, we have a product that's being raised to a power, so let's go ahead, apply the power rule to each factor one at a time. So I'm going to bust out a thinking area. I'm going to remind myself, if I have a factor and I'm raising it to some power, I'm going to keep the base and multiply the exponents. So let's do this. 3, when you raise it to the second power, that will give you 9. Next factor, when you raise it to the second power, keep the base and multiply the exponents. Y is y to the third, but you understand me. When we raise it to the second power, that will give you y. Product of the exponents is 6. One power rule down, one more to go. Let's go ahead and multiply that by. Okay, next product raised to the third power. Let's apply the power rule to each factor. First factor is 3. When you raise it to the third power, last time I checked, 3 times 3 times 3 was 27. Thank you. Next factor, raised to the third power, power rule. Keep the base and multiply the exponent. So that will give you x to the third power. Final factor, y. What's y to the negative first? Raised to the third power, you're going to keep the base and multiply the exponents. So product is negative 3. Okay, let's bring down the rest of the problem. Times 9x to the negative 9, y to the fifth. At this point, if you want to cancel out common factors, go for it. But you know what? This is actually like very hard on my eyes. So with your permission, we're going to multiply across. I'm not really going to simplify this product yet. We're going to multiply across just so we have a single fraction. When we multiply across, 1 times this is just that. Okay, so in the numerator, we'll have 9x to the negative 9th, y to the fifth. Okay, how do we get that? We multiply it across. 1 times this is just that. Okay, all over. I'm not going to simplify the denominator just yet. So we have 9x to the negative second, y to the sixth, times 27x cubed, y to the negative third. Okay, the reason why I multiplied across is just so it's a little bit more aesthetically pleasing. Okay, so you can do 9 times 27 without the use of a calculator, or you can love yourself and then cancel out the common factors. We got a 9 on top, we got a 9 on bottom. Let's do this. They cancel out. You can cancel out x's, you can cancel out y's, but for me, unlike the integers, canceling out the variables, it's really hard on my eyes. So now I'm going to go ahead and simplify the denominator by multiplying the variable factors. In the numerator, we just have this x and y. Okay, so we have x to the negative 9th times y to the fifth over, let's multiply the integers, then the x's, and then the y's. Okay, we got 1 times 27, that's just 27. Okay, product of the x's, silly exponent rules, they make me so mad. Do you have to be mad at yourself? Of course not, but you're not going to take the test for me, so I'm always going to write silly stuff like this. When we have a multiplication problem, you're going to keep the base and add the exponents. Product of the x's, we're going to keep the base and then add the exponents. Sum of negative 2 and 3 is 1. Cool, let me see if I can zoom in more. Okay, I think that's it. Okay, product of the y's, we're going to keep the base and add the exponents. Sum of 6 and negative 3 is 3. Fantastic. Oh, I'm crying because we've been here forever. So we got a fraction, okay? We have a couple of issues. One, we got a negative exponent. Why? Oh yeah, because we just simplify the denominator. What are the issues? One, we got a negative exponent, and two, we could still reduce it. Why? Because we got x's on top and bottom, and we got y's on top and bottom. So let's do this. So it's like, how am I going to reduce it? Silly exponent rules, they make me so mad. So I'm going to quickly remind myself, if I have a division problem, we're going to keep the base and subtract the exponents. So for quotient of the x's, we'll subtract the smaller exponent. The smaller exponent is negative 9. So let's do this. X to the negative 9 goes into itself once, and into the bottom factor, we're going to subtract that exponent. Okay, difference of 1 and negative 9, I think is 10. It better be 10, else I'm going to cry. Quotient of the y's, when we divide, we subtract the exponents. 3 is the smaller exponent, so let's do this. Y to the third goes into itself once, and into y to the fifth, we're going to subtract that other exponent. 5 less 3 is 2, so that will leave us with the y squared on top. Handle it, you got this. Go ahead, earn your grade. Product of 1 and y squared is just y squared, and in the bottom, product of 27, x to the 10th, and 1, you said it, is 27 x to the 10th. Okay guys, so I said we were going to do 7 problems, and we have reached the 7th problem. Hopefully, oh yeah, we did reach the 7th problem. Okay, so that is my time. Until next time, thank you.